Hello. So this video is going to be going over the remote learning activity March 26th on Thursday. This was going over inequalities. So you had to solve each inequality and write it in interval notation for every single one of them. Okay, so there was critical values, and some of them you had to test them. Some of them you did not have to. So in the first couple, these ones were where they were already kind of factored. So this one's already in factored form. You know that you have the zeros of 0, -1, 2, and 4. So you can go ahead and write those down, -1, 0, 2, and 4. Okay, over here, you know that this is going to be a degree of 4. If you were to go ahead and factor, you would get your leading coefficient as x to the 4th. Yes, it's both positive and it has the degree of 4, which resembles an even, or it resembles a quadratic, which has the end behavior as x approaches negative infinity goes positive, and vice versa for when x approaches, or same for when it approaches positive infinity. So then here you know your end behavior of your graph is both positive, and then from here there is no bounces because these are all even. Okay, so this is to the power of 1, 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 so there's going to be no bouncing on our graph. So then we have our answer over here. Notice that they are all parentheses because this is not equal to. All right, D is pretty much the same exact thing. This one here, you just had to factor it. You go ahead and get x plus 4 to the power of 2. When it's even, that is when you have a bounce. And yes, this is a quadratic, so of course it would be looking like this. So that's when you have that bounce, is when it's even. Odd is when it crosses. And then here, this is equal to, so you know that you're going to be including that -4. So your final answer is negative infinity to positive infinity. Okay, going to be this one here. This is where you're really going to have to use the bounce and cross. So this one here is even. It's a bounce. So at -7, you're going to bounce across the axis. And then here it is odd, so you're going to cross. Now, how did I know that this was going to have this end behavior? Well, taking a look here, we know the degree is odd because this is a 2 and that's a 3. If we were to go ahead and factor, if you were to factor this, you would get your leading coefficient to be x to the 5th power, and it's also positive. So the end behavior for an odd that's also positive is going to look like that. And then over here, how do I know what my solutions are? Well, if we take a look, this here says less than. So where is the graph less than 0? All of that. So you're going to go ahead and include those. This part here is just where it is not going to be less than 0. All right, and then taking a look, let's go to C. Taking a look at C, this is from the unit that we just finished up on before we got to trig. Over here, you find your x-intercept. That's when you take your numerator, set it equal to 0. Your vertical asymptotes is when you take your denominator and set it equal to 0. Remember, your vertical asymptotes are the restrictions. So this is where your graph cannot cross the lines. So over here, when I got those x values, I went ahead and drew them. I put -3, -2, and 3. At -3 and +3, I drew dashed lines to represent the vertical asymptotes to let me know that those are going to be open circles in a sense. You could put open circles if you want to. Doesn't really matter, but as long as you know that those are the vertical asymptotes, that nothing, your points will not be included. Okay, here this is equal to, so -2 is going to be equal to, so that is a closed circle. And then from here, you have to do test points in between all of them, and then you will find that you get your solution as bracket -3 to -2, close that bracket, union, bracket 3 to infinity. Then we go over here to the square root inequalities. The square root inequalities here, these ones are pretty much the same thing as when you would have a log. So if you remember when we had a log, so log base 2 of x plus 5 is less than 3. So two things that you would do is you would say, okay, x plus 5 is greater than 0. And then you would also go ahead and just solve this log. So you would solve this one here, and this here. And you would find those x values, and then you would put them on the number line to find where your solution would be as an interval. Now, it's the same exact idea, the same kind of process of you kind of have those restrictions. So over here, now instead of your restriction being the of, right, because we don't have a log, it's a square root, your restriction is inside of the radical. Okay, so we need to make sure that our radical, under the radical, it is greater than or equal to 0 when we have the square root of a negative number, right? We have, in our calculator, you get an error. Before Algebra 2, you would just say no real solution, right? Because it's a complex solution. So we don't want any complex solutions. Okay, so we don't want any complex solutions here. We only want real. So that's when you're going to go ahead, set that greater than or equal to 0. So you get this 1, 0, put it on your graph. Great. Go ahead and graph it. All right, and so then here, the next one, you go ahead and solve the original equation. Go ahead and graph it. Now, taking a look here, this is a less than and inequality, and it is equal to, so you're going to have here the two closed circles, and it's the overlap in the middle because it's an and inequality. The next one here is another and. Over here, you have to get the absolute value, the square root term all by itself. So you're going to bring that 6 over and then divide by the negative. When you do that, you flip the inequality sign. So be very careful. So you're doing the same thing. You're going to take the inside of here, get your restriction, and then go ahead and solve the full inequality. And then you have your overlap because this is an and, so less than inequality. Okay, and that is it. Thanks for listening.